Unit 6 today, we're going to talk about variation, all right? So variation has 3 different types. The first one that we're going to look at is direct variation, all right? So direct variation, the equation that you want to use or be familiar with is y equals kx, okay? Direct variation is a direct line. Think of it as a direct line or multiplication, okay? And your constant of proportionality, this is your k, all right? Some key words. How do I know when I use y equals kx? Yeah, so I need to see words like varies, directly, or words like directly proportional. Okay? Either way, you'll see direct, right? Directly. So what does this look like as a graph? Well, as a graph, it looks like a line with a positive slope or a line with a negative slope, right? The important thing that you need to know about direct variation is that it always goes through the origin. Your y-intercept is always at 0, 0. Okay? Here's the reason why. A variation is basically just a relationship, right? A direct variation is saying that as one goes up, the other one goes up. If one goes down, the other one goes down, okay? So the easiest example that I can think of is, do you guys work? Have you ever worked? Yeah? No? Yeah?
Yeah.
Yeah, right? Okay, well, even if you haven't worked, you know the system, right? How many hours you work depends on how much you're getting paid. Don't you think so? All right, so how much time you put in is how much you're getting paid, right? So if you put in 0 hours, how much are you getting paid? $0, right? So 0, 0. So, like this K, that's what tells us how much you're going to be making per hour, right? So if you work 5 hours, you get paid, say 5 hours at $5 an hour, then you get paid 25. If you work 10 hours at $5 an hour, then you get paid 50, right? So one goes up, the other one goes up, all right? So here's how we solve variation problems, okay? Always follow these steps. So you're going to see something like y is directly proportional to x, okay? Directly proportional, okay? And what variables do they use? Well, get the one before the words. So y is directly proportional to x, right? Let's write that equation. Y is directly proportional to x. Always have to have the k. And if you look at the next part, it says, and y equals 15 when x equals 3. This is what you need to use to find k. And you always have to find k. So y equals 15. I don't know k, but I know that x equals 3. How do I solve for k?
Divide by 3.
Yeah, divide by 3. So k equals 5. Now you're going to take that k and you're going to plug it in to your original equation. So now you have y equals 5x. All right, because you need that relationship link, and that is your k. So now it says find y when x equals 6. Right, so we don't know y. K equals 5. And x equals 6. So I'm going to plug that in. And then David said y equals 30. All right? Are we okay with that? Where did I get the 6? From here. Okay? So basically this whole statement, this whole problem is broken down into 3 different parts. You need to write down the equation. You need to find k. Plug in the k, and then you need to find whatever variable they ask you to. All right? Questions about this? Yeah. All right, so let's look at number 2. All right, let's try the same thing. Look for my key words. B varies directly with C. All right, B varies directly with C. B equals KC. Remember, varies means that we're always going to have an equals K. All right? So the next part, they say C equals 3 when B equals 4. That's what we're using to find K. B equals 4, I don't know K, and C is 3. K equals 4/3, yes? Now, we're going to rewrite this guy, and we're going to say B equals 4/3 C. Right? Because after you find that K, you need to plug it back into your original equation. Now, go to the last part. It says find C when B equals -8. So you're going to use your K to find C. So use your K equation, right? So B equals -8. Yeah? How do you solve for that C? Okay, so can't we do it all in one step? Multiply by the reciprocal of this fraction. What happens when you flip this fraction? 3/4. And that's the same thing that you just said. Alright, there we go. Okay. I mean, because really, you can multiply by 3 and then divide by 4. But if you multiply it by 3/4, it's the same thing. So I don't care which way you use. So what do we get here? Good. And there we go. Done. Pretty good, right? Yeah. All right. So I want you guys to go to the back of your notes. All right. We have some practice problems there. What I would like for you guys to do is I want you to try number 1. So on the back with your practice problem, so you need to do the first step. Write the equation. M varies directly with P. So M varies directly with P. Right? So the next part is what helps you to find K. So we have 75 equals K times 10. Well, you solve for K by dividing by 10, and you get 7.5 equals K. Yes? Okay. So then now you need to take your original equation, M equals 7.5P, and plug in your K. Now, this last part right there, find m when p equals 16. You're using your k equation to find that one. So find m, you have 7.5, and you plug in 16. What is your m? 120. Good. Pretty good. All right, so let's go back. All right, so let's go back to our notes. And let's take a look at another type of variation, another relationship. And this is called an inverse variation, okay? And with inverse, basically, you know, for direct, when I told you, if one goes up, the other one goes up, right? One goes down, the other one goes down. Well, inverse variation is one goes up, the other one goes down. Or one goes down and the other one goes up, okay? So then this one could be like the amount of money you have and how many pairs of shoes you buy, or shirts, or whatever. You know what I mean? Or how many things you buy. So if I start with this much money, right? If I buy more and more shoes, what's going to happen to my money?
Go down.
It's going down, right? So that is an inverse variation relationship. Does that make sense? All right. So what does this equation look like? Well, this one is y equals k over x. Right? It's a division. The other one was multiplication. So what is the constant of proportionality? Which letter? K. Good. K for constant. All right. So now, what are my key words? Well, yeah, varies inversely. Good. Varies inversely or inversely proportional. And when you graph inverse variation, it looks like this. You have a bunch of hyperbolas. I just thought it would be good to tell you what those graphs are called. Hyperbolas. All right, so let's take a look at our example. It still follows the same process. So we're going to start with the first part. Here are my key words. Inversely proportional. What is? M is inversely proportional to P. Right? That's my equation. Then I have when M equals 4, P equals 2. Well, that's what I need to use to find K. M is 4. I don't know K. P is 2. How do I solve for K? Yeah, multiply by 2. And whatever you do to one side, you do to the other side. 2 times 4, 8. So there you go. K equals 8. So now you're going to take that 8 and you're going to plug it in into your original equation for the K. Okay? Now, this last part here, you're going to use your K equation to find M. All right? m equals 8 over negative 8. So what is m? -1. There you go. So I don't know what situation this is, bless you, but when p equals -8, then my 8 is -1. When p equals 2, my m is 4. I mean, that's what we're doing, okay? So let's look at the next one. Good, you guys are doing a great job. All right, so the next one says, H varies inversely as G. Well, you gotta go in the order here. H and G, that's what I have. So, H varies inversely as G. So this next part is what I'm going to use to find K. H equals 1/2. I don't know K, and G equals -6. How do I solve for K? Good, thank you. Times -6. And guys, what's half of -6? Yeah. So K equals -3. So I need to go back to my original equation, and I'm actually going to plug in for K, right? So H equals -3 over G. Now we're going to use this last part here. We're going to use our K equation to find the last part. Right? We need to find G. H equals 63, -3 over G. Well, no, be careful. That -3 is actually on top, right? So, okay, this is what we need to do. You know what? This G is down at the bottom. Anytime your variable is down at the bottom, you got to get it out of there, all right? So you have a couple of options. You can multiply by G and then solve for G. Or, no, you know what? No, let's just do it that way. Multiply by G so we can get the G out of there. Okay, because you guys know that one. That G goes away. But look at what happens on the other side. You have 63G equals -3, right? Divide by 63. And then divide by 63. You actually had to move that G into its right location, and then you had to divide it out, okay? Kind of weird. So G equals negative what? Good. -1 over 21. All right? Anytime you have a variable in your denominator, that's what we need to do, okay? Get it out of there first. All right, so questions on this. All right, so let's look at this SOL question together. These are really important because they were really on the SOLs, okay? So this one says if y varies inversely with the square of x. Okay, keywords. Varies inversely. Well, what does? Y with the square of x. Okay, so then they want to know what is the constant of proportionality when y equals 10 and x equals 5. I'm just going to write that over here just because it's easier to see them together, right? And they only want us to find the constant of proportionality, so really all we're looking for is k, right? So just be careful when you go to write this. Y varies inversely with the square of x. This is not a square root. This is a square of x. Okay? Just be careful with that. So what is the constant of proportionality when y equals 10 and x equals 5? Well, x was squared. Don't forget to square it. Right? When you go and plug it in, you're only plugging in the number into your x, but that x was squared, so don't forget to put the square. 5 squared is 25. So 10 equals k over 25. What do you have to do to solve for k? Times it by 25. Good. So k equals 250, and that is your answer. All right. Okay, so let's try the next one. All right. So the time it takes to do a job is inversely proportional to the number of workers. All right. Sometimes they give you just word problems like this, okay? And you have to just determine the variables. But it's okay. Just look for the key words here. Inversely proportional. All right? Look in front of your key words. What does it say? Okay, so what are they talking about? Are they talking about the time? Are they talking about a job? Like, what are they talking about? The time. The time is inversely proportional. So we can call that T. All right? And it's inversely proportional to what? To what? Yeah, the workers, the number of workers. So we can call that W. So time is inversely proportional to the number of workers. Right? And then the next part is if 8 workers can do a job in 6 days, well, that's what we need to find the K. So let me plug that in. 8 workers do a job in 6 days. Well, 6 is the time. 8 is the number of workers. What is my K? 48. You need to multiply this by 8. And K equals 48. So then I'm going to rewrite my original equation by putting T equals 48 over W, right? Now guys, what are we trying to find? Are we trying to find T or are we trying to find W? Time. They said how many days? You need to find T because they gave you 16 workers. Is it 3 days? Yeah. Because 48 over 16, well, T equals 3. And then tell me the units, days. Then that way I know it's not hours or minutes or seconds. All right, so do me a favor, go to the back of your packet again, and we're going to try number 2. So I want you guys to take a few, I think a minute or two, and try number 2. David Bott.
I just want to try it.
For flying an airplane across the room, stand up and go pick it up. Why do you need to try it? You need to know what an airplane does?
I need to know how far it can go.
So in the middle of my teaching this lesson, David Bott, thank you for flying the airplane diagonally across the room. So with number 2, practice on the back, says R varies inversely with T. So when you go to write this, you should say R varies inversely with T. Yeah? the next part, if R is 168 when T equals 24, well, that's what you use to find K, because that's what we need to do first. So R equals 168, T equals 24. Well, you need to multiply by 24 to find your K, and what is K? No.
4,032.
Good, 4,032. So now you need to go and rewrite your original equation using your K. So R equals 4,032 over T. And then you can find the last part. Find R when T equals 30. Well, R, that's your K. T is 30. So what's your R? 134. Point, wasn't it point something? 134.4. Does it stop at 4?
Yeah.
Okay, good. Thank you. All right, so there you go. All right, so let's go back to our note 3. So the next part here, right? So they're asking you, is this inverse or is this a direct variation, right, Carlos? The thing is, they will ask you problems like this, okay? And they'll say, is it inverse, is it direct, or is it neither one of them? Well, let's think about this, guys. Inverse, what's the equation for inverse?
K, wait.
Okay, y equals k over x. Yeah, you had it, right? Tip of the tongue. How about direct? X, right? Direct, you're multiplying. Inverse, you're dividing, right? But if you look at both of these, they're both equal to what? Y. So if you want to know whether these are all, you know, whether they are direct or inverse, you need to first make them equal to Y. So let's look at the first one. If I want to make this equal to Y, what do I need to do? No, not minus. Divide by x. So then this is y equals negative 2 over x. What is that? Which one is that? Good. Good. That one looks like inverse because it is. This one is inverse. Yeah? Look at number 8. So you have y equals x minus 3. Huh? Does that look like inverse or direct? It's neither. Okay, you can't have that minus 3 there, right? So now how about number 9? How do I make this one equal to y? Good. Multiply by x. Good job. So multiply by x on this side. Whatever I do to one side, I do to the other side. Y equals 4x. What type is this? Good. This is direct. All right? Okay, so down at the bottom of your notes, now you have this big table. All right, so let's think about this. What are some of the similarities? What are some of the similarities or the things that they have in common between direct and inverse variation? Good, they're both equal to y. And what else do they both have? Good. They both have a k, which is your constant of proportionality. Good. Same steps. You're solving. What are some differences or things that they don't have in common? Well, no, they both have an x, but I guess it's more of like where the x goes, right? For direct, what is it doing? What operation? Multiply. Think of it as a direct line. It's going straight, okay? Direct is multiplying. Because it's y equals kx. How about inverse? What is inverse doing? Good. All right, so let's look at the next one. Joint variation. So now you know direct, you know inverse. Basically, those two are the only ones you need to know because they'll just keep mixing those two together. Joint variation, though, is basically direct, but you just have more variables. You don't have just x and y. You're going to have x, y, and z. All right? So joint variation looks like this. Z equals k x, y. Okay. Sure, Frank. Did I? Alright, Z equals kxy. And what is my constant? K. K for constant. I have to tell you my whole spiel on this K for constant. My rant. Anyway, the key words here. There's no proportionality statement. You're just going to see varies jointly. And that's when you know you just multiply. You're just going to have more variables. All right, so let's look at joint variation. We're going to go back and we're going to do the same thing because it's the same process. Varies jointly. What? What varies jointly? Z with x and y, yeah? So Z varies jointly with x and y. Now, when x equals 3, y equals 8, and z equals 6. Okay. This is how you find the k. Good. Good. And then?
Divide by 24.
Thank you. Divide by 24, and what do you get for k?
1/4.
Good. K equals 1/4. Now, you are going to rewrite this original equation with your k in it. And then the last part says find z when x equals 4 or negative 4 and y equals 7. Find z. Oh, sorry. We're going to use k equation. 1/4 times negative 4 times 7. You said what? Negative 7. Good. Mitchell, did you say 7 or negative 7? I heard you say negative 7. Good. Questions about this? Jose, you okay with this? All right. Jason, you good?
Yeah.
2 more seconds. All right, let's try the next one. Z. You know what? You guys want to try this? You try it. You try this one. So Z varies jointly with x and y. When x equals 1 and y equals 1/3, z equals 5. Now, of course, we don't know k. So 5 equals k times 1/3. How did you guys solve for k here? Okay, so you know what? Multiply by the reciprocal. If you flip 1/3, what do you get? Yeah, so multiply by 3. So k equals 15. So you're going to say z equals 15xy. Now, yep, you're going to plug in so you can find z. 15 times -4 times 7. What is that? What's 15 times -4 times 7? Good. Z equals -420. Good. So let's try number 12. I want you guys to try this. All they want you to do is find the constant of proportionality. So you don't even have to do the second step. Just find k. Number 12 says, y varies jointly with x and z. Find k. What is the constant of proportionality? Y equals 30, k, 4, and 5. So 30 equals k times 20. How do you solve for k?
Divide by 20.
Good. Divide by 20. And then what is k?
125.
Or it could be 3/2 or 1.5. All right? Good. So I want you guys to go to the back again, your practice problems,
Okay.
and try number 3. All right, so this one, y varies jointly with p and q. All right, so y varies jointly with p and q. If y equals 144, when p equals 12 and q equals 8, right? 12 times 8 is 96. How do you solve for k? Carlos.
Divide by 96 both sides.
Okay, and then what do you get?
3/2.
K equals 3/2.
Yeah.
All right, 3/2 or 1.5 again. Right, Mitchell?
Yeah, I got that.
All right, so let's go back to our notes and look at number 13. All right, put your phones away. Guys, we're almost done.
I'm tired. Come on, let's do it.
All right, so number 13. This is an SOL problem. All right? So with this, you're going to go and basically, even though it has a whole lot of words, just go and pick out your key words. Varies jointly. So before that, I'm going to take a look. What varies jointly? Huh? Volume. And we can call volume V, right? Volume varies jointly with the what? What about its radius? The square of its radius. Please don't leave that out, which is r. They give you that. So that's r squared. And its height, which is what? H. So there we go. That's our equation. Volume equals k, r squared times h. The next part is telling us how to find k, right? So let's plug it in. The container has a height of 10, so my h is 10. Yeah. A radius of 6, plug in 6. Wait a minute, what does a 6 need to have? Squared. I don't know K. And my volume is what? Yeah. So 377 equals K times what? What's 6 squared times 10? 360? And then in order to solve for K, I need to divide by 360. And you know what? That's going to be a really ugly decimal. So how about we just leave it as a fraction? 377 over 360, that equals K. Okay? So then that tells me I need to rewrite this equation. V equals 377 over 360 times R squared times H. So the last sentence is what I need to find, right? Using that new K equation. What is the volume? Oh, so we're trying to look for volume. My K doesn't change. It's just 377 over 360. What's my R? 4 squared. And H is also 4. Well, you know what? Let's think about that. What are they talking about? They're talking about volume, right? So when we're talking about volume, then we're probably going to use decimals. And then you have to round it. Let's round it to 2 decimal places. Okay? All right, 67.02. What's the number after 2? 2? Okay, then we'll leave it at 2, right? Cubic centimeters, so centimeters cubed. There we go. Okay? If you gave me the fraction, that's fine. It's actually more precise. But when we talk about like volume and all that stuff, we usually use decimals. Now we're going to look at writing variation equations. So with these, guys, all you're doing is you're just rewriting the equation. You're not just solving for anything. Make sure you look for your key words. So you have varies inversely, and you also have, look at that, directly. So you're going to have a two-step thing here. X varies inversely, so equals K. And if it's inversely, where does this Y go?
Bottom.
Bottom. And directly with Z, then where does the Z go?
The multi.
Yeah.
Up top.
Up top, because it's multiplying, right? Does that make sense?
Yeah.
So then let's look at number 15. My key words here, varies jointly. Oh, that's the only one? Good. All right. So let's see what we have. Y varies jointly, which is basically direct. We just have more stuff. With Z and the square root of X. Square root of X, guys. Okay? Did you put the square? Or did you just forget it?
No square root.
Square root. Now look at number 16. It says W varies inversely and jointly. Lots going on here. W varies. Where does inversely go? Bottom. So the X goes on the bottom. And jointly. Where do the jointly things go? On top. Y and Z, right? Okay? All right, so go to the back. Look at your practice problems. Now, you guys You should be able to do number 4, and you should try number 5. Okay? So number 4 should look like this. Yes? You got this?
Yeah.
Okay. And number 5, are you guys working on number 5 now? All right, so keep working on that. Good. So look, you have this weird word problem that looks so crazy, but look for your key words. Varies inversely. What does? The time. We can call that t, right? Makes it a little bit easier. So the time, blah, 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 varies inversely with the what? With the rate. How fast you can type, right? The faster that you type, right, the shorter amount of time it's going to take you to type it, right? So T equals K over R. When you're typing 35 words per minute, you can finish in 60 minutes. That's what you need to know to find your K. Which one is T? 35 words per minute or 60 minutes? 60 minutes equals K over 35. So how do you solve for K? Good. Multiply by 35. So K equals? Good. 2100. So let me rewrite this. T equals 2100 over R. Now they're asking you how many minutes will it take when you're typing 45 words per minute? Where does 45 go, for the T or the R? R. Good. It's gonna be what? 46.6 minutes?
Yeah.
Okay, so think about this. Somebody's asking you, Mitchell, how long is it going to take you? Are you really going to tell them it's going to take me exactly 46.6 minutes?
I'll probably tell them like 47.
Absolutely. Because that's what you need to do. When you're talking about time, when you're talking about people, because you would never say, I only have 46.6 people, right? Because that makes no sense, right? The only time you would have to get so precise that you would put decimals with the time is maybe if you're like a scientist and you really need to have it down to like significant figures. All right, things like that. So we'll just say it's going to take 47 minutes. All right? All right. All right.